Hello friends and welcome to another lecture on chemical engineering thermodynamics. Today we'll look into a problem that has come in Mumbai University CET1 question paper. This has come on December 19 and the question is 3B. The question is on your screen. The viral coefficient for ethane is B is equal to minus 15.67 10 raised to minus 2 meter cube per kilomole and C is equal to 9.65 into 10 raised to minus 3 meter raised to 6 per kilomole square. Calculate the isothermal work of compression for 1 kilomole of gas from 1 bar to 15 bar at 100 degrees Celsius. Compressibility factor Z1 is equal to 0.9949 and Z2 is equal to 0.9203. The viral equation of state has been given to you. Now, at the outset, let me tell you that this is V square. As you can see, the units are meter raised to 6 per kilomole square. So, this is V square. Now, how do we solve it? We know that the work is given by minus P into dV. So let's replace P now, and that's fairly simple here. We replace it as RT 1 over V plus B over V square plus C over V cube dV, and there's a minus sign here. Now we have the equation for work. Now if we want the work, we have to integrate this equation. So if we integrate it, we have dW is equal to W, and the RHS of this equation would be integrated as RT integral 1 by V plus B by V square plus C by V cube dV, and this would be from V1 to V2. Now all that remains is calculating V1 and V2. Now we know Z1 and Z2. So we know it as Z1 and we know Z2. Now let's note down. We have Z1 as 0.9949, that is 0.9949, and we have Z2 as 0.9203, 0.9203. Now this is at 15 bar and this is at 1 bar. Now let's calculate the values of volume at these conditions. So V1 is going to be equal to Z1 R T by P1, and that should be equal to 0.9949 into 8.314 into 373.15, that's 100 degrees Celsius in Kelvin, and to start with it was 1 bar, so it's 100 kilopascals. So we have V1. Let's go back to our rusty trusty calculator, and that's 0.9949 into 8.314 into 373.15 divided by 100, and that's 30.8654. 30.8654 meter cube per K mole. Mind you, I told you that the volume is in volume per unit mass. So V2, let's make a direct calculation now, is going to be equal to 0.9203. That's 0.9203 multiplied by 8.314 multiplied by 373.15 divided by 15 into 100. And that makes it 1.9034. That's 1.9034 meter cube per K mole. Now, our rusty trusty calculator comes to a help. So let's first calculate what is minus RT, and that would be 8.314 into 373.15, and that should be equal to minus 8.314 into 373.15, and that makes it minus 3102. So we note it down. That's equal to minus 3102.3619. 3691. That was not 19, it was 91. So we have the value of minus RT. Now we have the value of work as minus 3102.3691 integral of 1.9034, and no, the initial volume was 30.8654. 30.8654, and the final volume was 1.9034, and we have the equation. Now we write it down, minus B, which is nothing but 15.67 into 10 raised to minus 2, 15.67 into 10 raised to minus 2 over V square plus the value of C. That's 9.65 into 10 raised to minus 3. 9.65 into 10 raised to minus 3 over V cube and dV. The rusty trusty calculator. Do not try to simplify this equation. You can use the calculator to solve it. I always suggest that you buy FX 991 ES. Now, of course, I have not been paid by Casio, but since I have this calculator and I find it very, very convenient, so therefore I suggest all the students to buy it. Okay, that will be all about the calculator. Now let's start solving it. So now we have minus 3102.3691 into integral, and let's write the equation. So we put brackets first and we put this 1 over alpha x now that's minus 15.67 minus 2 alpha x square plus 9.65 minus 3 alpha x, and that's a cube. So we are pretty much done with writing the equations well. Now we need to put the limits. So the lower limit is 30.8654, and now the upper limit 1.9034. We are done. Plus is equal to, and we have our answer. That's 8407.64. So W is 8407 407.64. Now this work is in kilojoules per kilomole. And that's your answer, guys. It was such a simple problem. It did not require any effort, any integration whatsoever, just plain simple linear mathematics to a little extent and a little understanding on how do you write your integrals. So that was all about it, guys. Once again, if you want such interesting problems to be solved, if you're from any university, that is a university in South or a university in North, East, West, wherever, just write in the comment what is the problem you want to be solved, and I shall put the solution in the form of a video, which would be a good learning experience for you. So I hope this was a good learning experience for you. Have a great time. Stay safe. These are Corona times. Stay safe. Good learning. And keep learning from my channel. Keep learning thermodynamics. I'll someday make lectures on explaining you why thermodynamics is very important for a practicing chemical engineer. You shall see that lecture very soon. Goodbye. Have great times. Bye.